Hello and welcome to yet another video on data structures. So in this particular session we are going to study the method of linear search. So linear search is one of the most simple and straightforward searching techniques that can be employed to seek a particular element inside an array. So the key idea is that until and unless we find the element that we are looking for, we are going to traverse through the array. Okay, so we'll begin our search from the very first element. So the first element is at index 0. Let us say we want to look for an element that exists further away inside the array. So we will compare each element one by one with the element that we are searching for. And as long as no matches are found, we are going to continue searching through the entire array unless and until we find the element in question. So let us say I want to look for this one, 30. So after this I compared it with the next element, which is 50. So 50 does not match with 30, so I have to move on to the next one. So in the next step you can see we have finally found the number that is the key that we are looking for. So we were searching for 30 and we have finally found that. Okay, it is at index 2. So as soon as we have found the element that we were looking for, we can stop our search and then we can step out of the loop. So this is a very simple and straightforward process of searching, but the disadvantage is that if the list is very large, then the time required for searching will be also very high. So if the size of the array is say 5,000, 10,000 or even larger, so it will take a very long time, which will be proportional to the size of the array almost, to search for the element. So it will be a complete waste of time. More so if the element that we are looking for does not exist inside the linked list. So we will have to traverse the entire list from the beginning to end, and if the element is not found, all the time that we spend looking for the number will be wasted. So now let us see the code of linear search. So this is the C programming code of linear search. Okay, let us start from the main method. We have taken an array comprising of 7 elements as shown here. So n here gives the size of the array. What we are doing is we are taking the size of the entire array and then we are dividing it by the size of an individual element. So when we are dividing the size of the array with the size of an element, then we are getting how many elements are there inside the list. Okay, so if the size of the array is 14 and size of each element is 2, okay, array 0 means the element at the beginning. So we are dividing the size of the entire array by the size of the first element. So all the elements will be of equal size as it is an integer array. So if the size of the array is 14 and the size of the first element is 2, then it will give us 7, which is the total number of elements inside the linked list. So enter the element to search. So we are searching for a particular value. So we have taken it as input from the user. Now result equals linear search array n and key. So we are passing these 3 parameters to our linear search function. Okay, so we are passing the array as well as the number of elements and the value that we are looking for. So the value that we are searching for, it is stored inside a variable called key. So we are passing these 3 parameters over here. Now inside the linear search function, we are executing a loop that iterates n times, that is from 0 to n minus 1. So it will go through the entire array as long as it doesn't find the element that it is looking for, it will continue the search. So as I have shown you, it will try to match each and every element of the array with the key that we are looking for. So the key, say the value of the key is 30. So it will compare it with the first element So it will, if array I equals to key, return I. Okay. So if the match is found, then it will return I. That means it will return the index number at which it has found the value. Okay. So if it say we are looking for 30 and we have found it at index 30, so according to this code it will return the index where it has found the value. Okay. But if the value that we are looking for, say we are looking for some value that does not exist inside the array, so if it does not exist, then it will return -1. That means not found. And whatever value is returned from this function, it will be stored inside the variable result. So result will either store the position of the element if it is found, or it will store -1. So if the result is not equals to -1, so it will, after the value is returned, the control passes back to the main function. So if the value is not found, it is returning -1, otherwise it is returning the position of the element. So now it is checking what value has been returned to the variable result. So if it is not -1, that means the element was found. So it will then print the result. That means it will print that the element has been found at this and this index. Otherwise, if it is -1, that means the element was not found. So it will print element not found. Okay. So now let us take a look at the complexity. So complexity means how much time it will take to execute the code. So if it is found at the very first element, so if the number that I am looking for, say I am searching for 10 and it is found at the very beginning of the array, that is at the first position, then only one comparison is made, so the time complexity is ω1. Otherwise, if the number is not found in the array or is the last element, that means we have to keep searching through the entire array. That means we are going to make n number of comparisons till we find the desired number. So in that case, the complexity will be On. In average case also, it is θn, right? Because the key is equally likely to be anywhere in the array. So almost it will have to traverse through the entire array. Okay. Expected is n/2. So in case of complexity, we usually ignore the constants. So if the number of comparisons is n/2, by ignoring the constant 2, we are still getting θn, right? Average case. So this is the process of linear search. So I hope you've understood this, and in the next video we are going to see how to execute binary search. Thank you.